A few more times, so be aware of that. It's called what is that function gain? Now, so let's just play with this for a second. The initial solution, if we gave you that question in your exam, then the initial solution Dylan gave me is perfectly fine. The solution that is an alternate solution that Harry gave me is also perfectly fine. There are an infinite number of solutions, but I want you to make it as simple as possible. So I don't want you overcomplicating it. So the first decision you need to make is cosine or sine. And in this case, it starts at a peak. And we know that cosine functions start at a peak. If it started at a trough, we know that cosine functions start at that extremity. So you could do a negative cosine function, that starts at a trough. That would really help. If it starts at a midline, then it's a sine function, it's going to be easiest. But if it starts somewhere else, it's not a midline or a peak or trough, then either is going to be about the same. So you've got to make an informed decision, and you want to make your life a bit easier. Remember how we draw it using a box? And I say we pretty lightly. This is the way I do it. You may not have adopted this. That's up to you. But I draw one period, one cycle in one box. So I'm going to say here, straight away, that my phase shift for a cosine function equals 0. Phase shift. There we go. That's the first thing. I can see here that my period, which equals t, is pi. It's got a period of pi, and that implies, of course, that my b value equals 2 pi over t, which equals 2 pi over pi, which equals 2. So I've got a b value of 2. I'll do this in a different colour so it stands out. No, that's probably not the best one. Let's go red. It's got a peak of 5 and a trough of -3. Now, it turns out my midline is 1, but the midline is not always easy to see. Sometimes, particularly with really elongated, tall graphs, it can be quite hard to see. Is it 1? Is it here? Is it here? So I actually wouldn't worry too much about the midline. If you know the peak and trough, well, then you can work out A is equal to the peak minus the trough. Is that right? Yep, good, over 2, which in this case is 5 minus -3 over 2, which equals 4. So to find the A value, you just work out what this gap is, which is worth 2 amplitudes, and divide it by 2. And the D value is equal to the opposite to that, the peak plus the trough over 2, because that's an average then. The D value is the average of your peak and trough. And of course that gives us 5 plus -3 over 2, which is 1. Now you might be thinking already, if I get a question like this in the exam, this is not on the formula sheet, I'm going to get that wrong for sure. I've got a 50-50 chance of getting that the right way around. This is an average, and this is finding the amplitude based on 2 amplitudes being between there. So you might be able to remember it like that, but let's really be honest. If you know what the amplitude means and what the midline means, if you get a midline of 4, you're going to look at this and go, that's not the midline. So if you get it the wrong way around, it's going to pretty much be obvious most of the time. Not all the time, but most of the time. So you're going to take a second, get your answer, have a look, and you'll be able to determine if you've done that wrong. Anyway, I've got an A, I've got D, I've got that. My phase shift is 0, which implies that my C value is 0, and that means my function is Y equals 4, which is my A. Cos was what I decided to use, not 4. I was thinking 2, and I wrote 4. 2x plus 1. Now, I don't have a C value, so I don't have to put that in there, which means I don't need to employ brackets inside my function, but you can. There's no harm. If you're not sure, go with brackets. And that's it. Now, Harry's one's perfectly good as well, but we've just taken the phase shift to be out to this one here. And if you're working on the premise that my phase shift is always to the first peak or the first midline going up, and you end up out here, well, that's fine. So the other solution that Harry had was y equals 4 cos 2x minus pi plus 1. And for that matter, the next peak's out here at 2 pi, so it could be x minus 2 pi. Or it could be x plus pi, that would be back there. But it's the same thing, because if we shifted a whole period, it's exactly the same function. Now, the last little extension was that if I wanted to do a sine curve, my phase shift is now to here or to here. It has to be at that midline heading up. How do I determine that value? And the biggest complaint I had about that was that I chose for this question to have a really dodgy scale that doesn't make that phase shift obvious. But you do have to remember that on the scale, remember I said that the minimum requirement is you give me one number on the scale? If you've got one relevant number to the graph, you can find anything. So I know that I've got a period of pi, and this occurs in quarters. So it goes from peak to midline in a quarter of a period, midline to trough in a quarter of a period, trough to midline in a quarter of a period, and then midline back up to the peak in a quarter of a period. So I actually want to move, I want my phase shift to be 3/4 of the period, which is 3/4 of pi. And so the other alternate solution would be y equals, my amplitude stays the same, I'm using sine this time, my period stays the same, or my b value, and now I've got x minus 3 pi on 4, or 3/4 pi, or however you want to represent that, and then my midline stays the same. Between sine and cosine, the only thing that changes is that phase shift. That's it. Well done, you've played our first iteration of what is that function. Well done. Any questions? Well, that was fun. My intention for today is to pretty much give you time to work on some of this stuff. Tomorrow we're going to go through and start doing solving trig equations, but for today it's going to be practicing this from the exercises, which were something. So good. So good, Sophie. You could be the teacher now if you want, because I can't remember those exercises. Okay, cool. Thanks.